Okay, so in our class today, we're going to get into arithmetic sequences. And to begin with, we're going to first demonstrate, we're going to first learn how to show that a sequence is arithmetic. And then after that, we're going to look at how to find a formula for the general term of an arithmetic sequence. So what makes a sequence arithmetic? The key is that the common difference between consecutive terms is constant. So D is a constant. And so this can be, for example, the first term and the second term, or the fifth term or the sixth term. They have to be consecutive, and this is always a constant difference. So this is how we first show that a sequence is arithmetic, and then how can we find the general term, or the general term for an arithmetic sequence? Well, first we have to know how the general term looks like. So the general formula looks like this: U of n is equal to U of 1 plus n minus 1 times d. So I'll explain every term right now. This is the term. For example, if U of 1 would be the first term, U of 5 would be the fifth term. So this is I'll just write the term. And this is the first term, so it's U of 1. And this is the n, so this is the term number, this one, and this is the common difference that we just found above. Okay, all right, I'm gonna go to an example now. So just to, so that's the common difference D right there, like that. Let's see how this looks like in practice. Okay, so consider the sequence 2, 9, 16, 23, and 30. Show that the sequence is arithmetic. All right, so how do we show this is arithmetic? Remember what I said above. We have to make sure that consecutive terms produce the same common difference. So, I mean, in this one here, oh, sorry, I can't find my mouse. So in this case, let's say the second term is 9, first term is 2, so that common difference would be 7. Third term minus the second term, still 7. We can check again, but usually 2 is enough, but we check again. 23 minus 16, that's the fourth term minus the third term. Still 7. Okay, so this is A done. This just proved that, well, we didn't prove, but we showed that it's arithmetic. Okay. Find a formula for the general term U of n. All right, let's try this one out. So we have D. D is 7. So D is equal to 7. Now what we need is the first term, U of 1. And you'll see why n minus 1 here is like this when we apply this to this equation. Because I'm sure some students see this and they might think, why is it n minus 1 and not n? nd, for example. Okay, U of 1 is very easy. U of 1 is just 2. Okay, and let's just plug that into the equation. So U of n is going to equal to 2. I might just write the equation again. U of 1 plus n minus 1 d, that's equal to 2 plus n minus 1 is just n minus 1 times 7. And then we can expand that to 2 plus 7n minus 7. And then we can move that 7 over, minus that from 2. So that's going to be 7n minus 5. Now we can see here that U of 1 is going to be 2. And that's why we need that n minus 1 in there. Because if we didn't have n minus 1 and we just had nd, for example, if u of n was just 2 plus 7n, then the first term would be 9. So that's why this doesn't work. Okay. All right. So that's the first two parts of this example done, but there's some more. So let's look at what else there is. So we have to find the 100th term of the sequence. Well, we know that u of n is equal to 7n minus 5. So the 100th term is just going to be u of 100. And that's going to be 700 minus 5, which is 695. So now this is the easy part now. Okay, D. Is 828 a term of the sequence? 828 or 2341, both of them. So let's first do 828. So that just means that we have to check if u of n equal to 828 is a term in the sequence. So the way to do that is to equate 7n minus 5 to 828. Oops, sorry. 828. And if n is an integer, when we solve for n, then it is a term in the sequence. So 7n is equal to 833. And you can just plug that into the calculator or do it in your head. But you'll find that this is indeed a term in the sequence because it should be 119. So yes, this one is 2341, 2341. So let's look at that. U of n is equal to 2341. Sorry, maybe I just do this. 7n minus 5 is equal to 2341. So 7n is equal to 2346. And you'll find that this, when divided through, n is equal to 335 and 1/7. So this is not okay. Not a member. So it is a member and not a member. Okay. All right. So I won't do any more problems with this, but I will tackle some more different types of problems. One more example. Okay. So this is a very common problem in exams. Find k given that 3k plus 1, k, and minus 3 are consecutive terms of an arithmetic sequence. So the way that I would do this is k minus 3k plus 1. Remember to keep the brackets. This would be the first common difference. The common difference between these two terms. Sorry. Oh yeah, common difference. Because yeah. So we can just simplify that a bit to minus 2k minus 1, and then we can find the common difference between these two, or just the difference, minus 3 minus k. Okay, so these two should be the same. These two should be the same because it's an arithmetic sequence. And so minus k, 2k minus 1 minus 3 minus k is going to equal to minus 3k minus 4. Oh, I'm sorry. Whoops. So minus 2k minus 1 is equal to minus 3 minus k. And so now we can find k. We can add 2k to the other side, add the minus 3 over as well. So that's going to be 2 is equal to k. Therefore, k is 2. Very easy, this question. Okay. I'm going to just keep hammering through the examples. Find the general term un for an arithmetic sequence with u3 is equal to 8 and u8 is equal to minus 17. Okay. So this is adding some difficulty now. So the key to doing this is to remember the general term. This looks like what we wrote before. Okay, so u of 3. u3 is going to equal to u1 plus, we sub the n in. So 3 into that, 3 minus 1 is 2, so plus 2d. U of 8, same deal, but plus 7d. Okay, and now we have to find our two variables, which is u of 1 and, sorry, maybe I can equate them first. So this is equal to 8, and this is equal to minus 17. And so, yeah, and so we can try to find u1 and d. These are it's simultaneous equations now because we have two variables u1, d, and d. And so the way I would do this is probably u8 minus u3. And so the u1s cancel out. And then it's 7d minus 2d, which is equal to 5d. And that's going to be bottom minus the top, which is minus 17 minus 8, which is minus 25. So 5d is equal to minus 25, and therefore d is equal to minus 5. And u1, so let's try and find u1 now. So if we sub that back into u3, which is the easier one, it's going to be u1 plus 2d is equal to 8. So u1 minus 10 is equal to 8. And so u1 is equal to 18. Oh, sorry, maybe I won't circle this. And so now we can find, so we have d here, and we have u1. So un is equal to 18 plus n minus 1 times d is minus 5. And we can simplify everything. 18 minus 5n plus 5. So it's going to equal to 23 minus 5n. Like that. Okay. Cool. U of n. All right. I'm going to do 2 more examples. Insert 4 numbers between 3 and 12 so that all 6 numbers are in arithmetic sequence. Okay. So the key is still the general formula. U of n is equal to u of 1 plus n minus 1 d. So let's take a look. We have 3. So we have 3 and 12, and we want to put 4 numbers in between them. It's going to be 3, comma, blah, 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 comma, blah, 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 comma, blah, comma, blah, comma, 12. So the key is to find what is this? What's in between? Okay. All right. So if 3 is the first term, U1, then the second term is going to be, so U1 is just 3. Well, the next term is just U2, which is 3 plus D. U3, that's going to be 3 plus 2D. U4, that's going to be 3 plus 3D. U5, 3 plus 4D. And U6, 3 plus 5D, which we also know is just 12. So from this U6, we can actually find D, and then we have all the terms. So 3 plus 5D is equal to 12. That means that 5D is equal to 9. That means that D is equal to 9 over 5, which we could write as 1.8. And if you just plug them back into all the past equations, all these equations, you get that the sequence becomes 3, 4.8, 6.6, 8.4, 10.2, and 12. Okay. All right, I'm going to do one last example. Ryan is a cartoonist. His comic strip has just been bought by a newspaper, so he sends them the 28 comic strips he has drawn so far. Each week after the first, he sends 3 more comic strips to the newspaper. Find the total number of comic strips sent after 1, 2, 3, and 4 weeks. Okay, this is super easy. The first week is 28 because they tell us in the question here. So week 1, 28. Week 2, well, 3 more every time. So 28 plus 3, 31. Week 3, we can just 31 plus 3, 34, blah, blah, blah. Week 4, 37. Show that the total number of comic strips sent after n weeks forms an arithmetic sequence. Okay. So, there's a common difference D. Sorry. Common difference D is equal to 3, and U1 is equal to 28. That's basically it. You can write a bit more, but it's not going to pop up in an exam. Find the number of comic strips sent after 15 weeks. Okay, so what's the general term U of n? This is the key. The key is 28 plus n minus 1 times 3. So some students might write 28 plus 3n, but it's not. It's 25 plus 3n because U1 needs to be 28. And so what we have here is we're trying to find U15, 15 weeks. So U of 15 is going to equal to 25 plus 45, which is 70. So after 15 weeks, he sends 70 comic strips. When does Ryan send his 120th comic strip? Okay. U of n is equal to 25 plus 3n, which is equal to 120. So 3n is equal to 95, and n is equal to 31 2/3. So it's in the 32nd week because it's already past the 31st week. So Ryan sends his comic strip, sends his 120th comic strip in the 32nd week. Okay. All right. So that's arithmetic series done. IBAASL. Thank you for listening. If you've come this far, thank you very much. I will attach this a photo of this if anyone needs it in the description below. And please subscribe if you found this helpful. Thank you.